Okay, so this is section 4.5, and it is called solving by finding the square root. So I want to first look at the problem x squared minus 16 equals 0. So we looked at problems like this in the previous section in which we solved by factoring. Okay, so x squared minus 16. These are both perfect squares, and it's subtraction. Okay, so this type of factoring is called the difference of two squares. Right, they're both perfect squares and there's a subtraction in between. So if we wanted to solve this by factoring, we would first work with the left side. So x squared minus 16 means we would have x plus 4 and x minus 4 equals 0. With the difference of two squares, you take the square root of the x squared, you take the square root of the 16, and one's going to be plus and one's going to be minus, so that the middle term cancels out to 0. Right, and then my two answers will be negative 4 and positive 4. Okay, so important things to note here. In general, we get two solutions. Okay, and often one is positive and one is negative. So we're going to look at a new way of solving these. So for your notes, this is section 4.5, and we're going to solve quadratic equations by finding square roots. And you're going to need to know what we worked on yesterday, right? How to simplify square roots in this section, because all our answers are going to have to be simplified. Okay, so there's 4 steps that we need in order to solve using square roots. So the first step is to isolate the base and the power, the base and the exponent. Okay, so the first thing you want to do is look at the problem and determine what is the base and what is the exponent. So the first problem I gave you is pretty straightforward. There's my exponent. My base is just x. So this is the term that I want to get by itself, that I want to isolate. I would do that by adding 16 to both sides. So I end up with x squared equals 16. Step 2 is take the square root of both sides. And if I want to get the x by itself, I want to get rid of that squared. The opposite of squared, or the inverse operation of squared, is the square root. So take the square root of both sides. All right, so I'm going to take the square root of both sides. And whenever you take the square root of x squared, it's impossible to know whether x is positive or negative, right? I could square 4 and get 16, or I could square negative 4 and get 16. All right, so whenever you take the square root of x squared, you need to remember to add in a plus or minus. Okay, so that's step 3, to remember the plus or minus. That's how we're going to get our two solutions, right? It could be positive 4, could be negative 4. And then step 4 is to simplify the square root. In this case, 16 is a perfect square, so it's just 4. But in some other problems we're going to look at, we're going to need to simplify the square root, maybe worry about the denominator, but these are our 4 steps. All right, so I have a few examples to go through. So we're going to do a few together, and then I want you to try the ones in the back by yourself. Okay, so 4x squared minus 25. First thing I'm going to do is notice that my x squared is right here, right? The exponent is the 2, the base is just the x. It's just an x that's being squared, so that's what I want to isolate. All right, so in order to do that, I'm going to add 25 to both sides. So 4x squared equals 25. Divide by 4. And I'm going to leave this as a fraction. Notice that the denominator is a perfect square. That's what you want, because when we take the square root, we're not allowed to have any square root symbols in the denominator. So if you already have your denominator as a perfect square, that's how you want to leave it. Okay, so we've isolated the x squared. Step 2, square root of both sides. So x equals plus or minus, right? And then the square root of 25 over 4 is the same as the square root of 25 over the square root of 4, right? We just take the square root of each one separately. So that's 5 over 2, and I'm going to write my answers as a solution set with curly braces. So there's my 2 solutions. So in general, we should get 2 solutions to these. All right, let's look at B. X squared minus 20 equals 0. So isolate the x squared. So x squared equals 20. Step 2, square root of both sides. Step 3, remember that plus or minus. The square root of 20 needs to be simplified. All right, so over on the side, I'm going to think about 20. So 20 is 4 times 5, and 4 is 2 times 2. I have 1 pair of 2's with a 5 left over. So for each pair, for each pair, 1 comes out and the 5 stays inside. So my solutions are 2 square root 5, negative 2 square root 5. All right, so this one is similar. 5x squared plus 8 equals 30. So subtract 8 from both sides. So 5x squared equals 22. Divide by 5. So x squared equals 22 over 5. That was my first step. Okay, now we're going to need to see something new in this problem here that we haven't talked about before. Okay, so I took the square root of both sides, so x equals plus or minus square root of 22 over the square root of 5. I'm just going to write them each with their own square root. Okay, so notice I have a square root in the denominator. We're not allowed to leave square roots in the denominator. That's considered not simplified. The way you get rid of a square root in the denominator is by multiplying by itself. Okay, because the square root of 5 times the square root of 5 is just regular 5. And with fractions, whatever you do to the denominator, you need to also do to the numerator. Okay, so 22 times 5 is 110 over 5. And I don't want to lose my plus or minus. All right, so again, whatever is in the denominator, whatever square root you have, you need to multiply by that same square root in the numerator and the denominator. So my 2 solutions are the square root of 110 over 5 and the negative square root of 110 over 5. Now the square root of 110 can't be simplified. If it could, you would want to simplify the numerator as well, but that's it for C. Okay, D looks a little different. So notice my squared, I'm squaring x plus 2 this time. My base is x plus 2. So this is what I want to isolate. Okay, so step 1 is to get this by itself. All right, so same steps as before, subtract 5. So 3 times x plus 1 squared equals 36. To get rid of this 3, I want to divide both sides by 3. So I have x plus 1 squared equals 12. Okay, that's step 1. I've isolated my base and my exponent. Take the square root of both sides. I have x plus 1 equals plus or minus 12. Okay, now I'm going to simplify this right here. Okay, so 12 is 4 times 3, and 4 is 2 times 2. So I have one pair of 2's. Okay, one pair of 2's, so 1, 2 comes out. The 3 stays in the square root. And then my last step is to solve for x. I haven't finished getting x by itself. So I'm going to subtract 1 from both sides. So these are not like terms. This has a root, this doesn't, so I'm just going to write them both down. So negative 1, and then I have plus or minus 2 root 3. Okay, so my two answers, you can leave it like this, that's fine. My two answers, if I wanted to write them out, would be negative 1 plus 2 root 3 and negative 1 minus 2 root 3. All right, and then the last two examples, pretty similar. I have x over 5 squared. X over 5 is my base. That is what I want to isolate. So add 27 to both sides. Okay, so step 1 is complete. I've isolated my base and my exponent. Square root of both sides. So I end up with x over 5 equals, remember the plus or minus. Okay, 27 I'm going to break down as 9 and 3. And 9 is 3 and 3. A pair of 3's means that 1 3 comes out. 1 3 is left over. Okay, and last step, get x by itself. To get rid of this 5, I'm going to multiply both sides by 5. Okay, so I end up with x equals plus or minus. Now remember, when you multiply, you don't need like terms, right? Numbers that are outside get multiplied together. Okay, so 5 times 3 is 15, and I keep the root 3. Okay, and then the last example is right here. So negative 6x squared plus 8 equals 0. There's what I'm trying to isolate. So I'm going to subtract the 8. So negative 6x squared equals negative 8. Divide both sides by negative 6. So I end up with x squared equals 8 over 6. I'm going to simplify this before I take the square root. So 4/3. Take the square root of both sides. So x equals plus or minus. Okay, so this is the same as the square root of 4 over the square root of 3. Right, the square root of 4 is 2. And the square root of 3 can't be simplified. Now this is another case where we need to clean up this denominator. This is called rationalizing the denominator. You can't leave a square root in the denominator. So you just multiply it by itself. And whatever you do to the denominator, you have to do to the numerator. So x equals plus or minus 2 root 3 over root 3 times root 3 is regular 3. So there are my two answers. All right, so I want you guys to try the ones on the back. we will go over these tomorrow. And you can email me if questions if you want, or you can just save them for tomorrow.